Hello, my name is Mike Weber. I'm not Phil Bruner, sorry. All right, so since about 2009, some people from our group have been using geolocators to study the migration routes of Pacific golden plovers. And this year, we decided to try something new. We used some solar-powered satellite transmitters. We attached such a transmitter to 5 plovers at the BYU campus on Oahu, and then we did the same thing to 5 plovers in Nome, Alaska. So I'll be talking about that. Here's some old results that were presented here. In 2009 and 2010, we learned that the plovers from Hawaii, they fly pretty much directly to Alaska and then return pretty much directly to Oahu. On the other hand, plovers from Saipan and other southern Pacific islands, they do not fly directly to Alaska. They go to Japan first and then to Alaska. And this was also verified with the birds from Kwajalein. Now, these studies that I just discussed briefly, they were done with geolocators. A geolocator is just this tiny little data logger that's placed on the leg of the bird, as shown. They have a small mass, 2 grams, including the epoxy and so forth and so on. What these geolocators do is they measure the light levels every single minute, and then they record the maximum light level every 10 minutes. Now, what good is that? Well, one can use these light levels to figure out the sunset times and the sunrise times, and from that, you figure out the longitude and the latitude. These geolocators also measure the potential contact with seawater. And of course, that's important because you want to see if they're if they're flying directly from Hawaii to Alaska or if they're stopping. Pretty cheap, $500 each. Of course, well, you'll see. Hold on. It's all relative, right? Okay. The data is stored in the geolocator. Now, what that means is you have to wait until the birds, let's say, return to Oahu, and then you have to catch them and take the geolocators off and then download the data. Now that sounds pretty easy, right? Well, it's not. We found it was very easy to initially capture a plover, to band it, and to attach the geolocators. Pretty much what we use is a net gun or sometimes a mist nets. We heard a little bit about that yesterday. Again, if they've never been caught, they're not afraid, and it's pretty simple. On the other hand, once they've been banded, it's very, very difficult to recapture them. They seem to have a tremendous memory. They see you coming, they see the net gun, or they see the van or whatnot, and they just fly away. It's very, very difficult. I like to say they're highly intelligent, unfortunately. Here's some numbers. 2009, 2010, 22 of the 24 birds that were tagged returned to Oahu, and 20 birds were recaptured. That's pretty good. In 2012, we went over to the Big Island of Hawaii, to the Hilo side, and there were 10 birds that were tagged, and we recaptured 8. However, it took 4 trips to Hilo to capture these 8. It was not easy at all, which is kind of it's a real disadvantage. Okay, obviously there are some uncertainties with this light level measurements because there are shade variations, weather, trees, artificial light, so forth and so on. Here's the uncertainties for these geolocators. For fixed locations, you can pretty much get the position plus or minus 100 kilometers. When they're in flight, plus or minus 200 kilometers. Right, the data analysis. The data analysis, you use a software program that's issued by the manufacturer. Let me just say it's very hands-on, it's not automatic, it's cumbersome, and it's time-consuming. You really have to, you set a threshold level for the light levels, and you have to go through by hand and just throw away data where the light levels aren't high enough. This is a picture of that we made from a partially processed data file where the light level cuts have been made. Now obviously you see a lot of nutty results on that, so the further processing requires you to delete data which have unreasonable longitudes and latitudes. As far as the geolocators, they're highly reliable. There's the reliability. What I mean by that is, the birds travel from Hawaii to Alaska and back, and pretty much most of the geolocators work after we recapture them. All right. So last year, one of our collaborators, Lee Tibbetts from U.S. Geological Survey, she suggested that we try these solar-powered satellite transmitters. They're called PTT, Platform Transmitter can't remember, who cares? These are made by Microwave Telemetry Incorporated. So look at the size. They're really, really small. 24 million, well, like that. They're really, really small. You can see the dimensions there. And what's impressive about them is the low weight, the low mass, 5 grams. Now that's obviously larger than the geolocators, but it's still pretty small. So we thought we'd give these a try. And I'm going to explain to you why we thought it was worthwhile to give these a try. All right. First of all, these things are attached to the back of the bird. By the way, that's not a plover, right? Okay. So these are attached to the back of the plover. We sort of use a harness, Teflon tubing or something like that, to attach these to the back of the plover. What they do is they transmit signals to the Argos system of satellites. And what's wonderful about it, the locations are calculated daily. So we don't have to do any data analysis. We get a file sent to us, we look at it on Google Earth, and bingo, it's very wonderful. Here's an example of a data file that we look on Google Earth with. Pretty nice compared to the geolocator. Okay, now if you look at the manual, the stated location error is less than 250 meters, which is amazing, right? However, Lee Tibbetts sent me a paper, and some scientists did some studies on the position errors using this system. And there's different classes of data. For the best class of data, they said that the location error is more like less than or equal to 5 kilometers. All right, that's much larger than 250 meters, but come on, it's still better than 100 kilometers or 200 kilometers for the geolocator. So we thought, wow, this is going to be fantastic. The duty cycle, 10 hours on, 48 hours off. And they use the Doppler Effect to calculate the locations. And these impressive high school students, you should go back and ask your physics professor or your physics teacher what the Doppler Effect is. Basic physics. Now here, okay, so remember I said that the geolocators were cheap? Here's why I said that. These PTTs cost $3,400 each. Not only that, now remember, we're not doing any data analysis. They do it for us. Well, they don't do it for free. It's $50 a month, and that's per, it's $50 a month. So it's not cheap. So what we did this year, we captured 5 plovers on the BYU Hawaii campus, and we put these PTTs on them. And we wanted to see how they would react. And so we made sure that we put them on a few weeks, many weeks, prior to the migration to Alaska. And what we found, for the first few minutes after we put these backpacks on, they seemed not to be all that comfortable, but after a few minutes they were fine. And then we monitored them before they left to Alaska, and they just acted normal. You know, they would fly around and come back and fly around and come back, and everything seemed to be really, really fine, which was real positive. Yeah, nothing unusual was noted. So then, finally, when it was time for them to leave, they left, and out of the 5 that we had these PTTs on, 4 reached Alaska. And there's a nice Google image shot, Google Earth shot there. And what also was nice is their travel speeds and their travel times were similar to those that we found with the geolocators. Again, that's giving us more confidence that, hey, maybe this is a way to go. So then later in June, some of the individuals from our group put some PTTs on 5 different plovers in Nome, Alaska. Again, you know, enough time before they return. So again, we're all positive, thinking things are going to go well. All right, so here's the results now. Not so great. Of the 4 plovers that left the BYU Hawaii campus, only 2 returned. So we're assuming that most likely 2 died. And we can say that because some of us have been walking around campus looking for, you know, maybe the PTT came off or something like that. Well, so we walk around campus. So some of us have walked around campus looking for those banded birds because they have color bands on. We know which ones we put the PTTs on, and we haven't found them. And plovers are very, very site faithful. So the fact that we haven't found them sort of indicates that something not nice happened. Okay. One thing that was kind of interesting, one of these 2 plovers that returned to the BYU Hawaii campus decided to take he flew to the Big Island first, so that's southeast of Oahu, and then had to turn around and come back. So that's about, 400 miles extra he flew, and that's kind of interesting. That actually happened to a couple of the plovers from 2010. And so you wonder, why would you do that? Why would you make that extra travel? Well, perhaps the winds, perhaps the cloud cover, who knows? Okay, and here's some other bad news. Out of the 5 plovers that we tagged in Nome, only 1 survived. And this one's kind of interesting. So it left Alaska, and then it flew to Okinawa, and it stayed there for a few weeks. In fact, one of Wally Johnson's friends in Okinawa took that photograph. So there it is. Stayed there a few weeks or so, and then flew off to Indonesia. So you can see. And the last time I heard from Lee Tibbetts, that's where it still is. That's quite a flight. Okay, so you notice I use black. There's a reason for that. Let's talk about these mortality rates. So, we're all wondering, what went wrong? I mean, things went pretty well getting to Alaska. Not perfect, but pretty well getting to Alaska. So what went wrong? So, people have ideas. So here are some of the ideas that I've heard. Perhaps they just didn't get enough food when they were in Alaska. So they were depleted after eating it. They just didn't have enough strength to make the flight back. Difficult headwinds. That would count for a lot of trouble. Maybe there was some kind of an aerodynamic problem with the PTTs. I don't know about that. The birds that returned to the BYU campus, a lot of the feathers had grown over the PTTs, and it's not like they were sticking up or something like that. So I don't know. I kind of think that it's probably a combination of these 3 things and maybe something else. As far as the future studies, next year we're going to put some geolocators on some plovers in Tahiti and study those. We're also thinking about perhaps going back to the PTTs from some birds with Saipan, but we're not really sure yet. People are sort of cautious now. Maybe we're only going to put the PTTs on the birds that can go from here to Japan and Alaska or something, so they'll have plenty of time to fatten up. We don't really know yet.